appreciate everybody taking time to talk to us. Hopefully everybody can hear us. If not, you're having problems, please message us in the chat. There's also the questions and answers section, which you can ask questions and we'll answer those at the end of the session as well. So I'm Jonathan Halstuch, and I'm going to be presenting on Zero Trust Protecting Data at the Source. I am the CTO and co-founder of Racktop Systems. I spent 20 years working in the IC as a government employee, and I founded Racktop based on my experience working 15 years at NSA. And so we've taken that experience and tried to embed our experience and knowledge to make a product that's simple to use, and so anyone can get the benefit of our experience. And so my co-founder came out of NSA, and a lot of our developers and support team have experience working within the IC, and we have customers as well within the SAP community. And you can follow me on Twitter at JAHGT. And so at Racktop, we consider ourselves the pioneers of cyber converged data security. A little bit about that, which is we're converging security and data storage into a single platform, and we're doing that through a software-defined NAS, where we embed the security and compliance capabilities into the storage operating system. But today I want to talk to you about Zero Trust, which is a concept that was developed about 10 years ago by a Forrester analyst, and of late has been getting a lot more attention and has been kind of a thing that people are thinking about more. And it's really not something you can buy, but rather a way of thinking and a process to implement, and something that you can go about within your environment. So I'm going to kind of go through why it's important, and then the security and issues around data and how you can think about this in your environment as well. So data here is our mascot, and in a normal organization, data accounts for 80 to 90% of the organization's digital assets, and most of that data is unstructured data. So you can think about it as Word files, documents, Excel spreadsheets. Even a lot of times, if you have structured data, and structured data we consider like databases and things like that, people often are exporting that information out of the database. You can imagine people would export data out of an HR database, and now you have PII or sensitive data in the spreadsheet. So we see that type of information, export and manipulation happening all the time. So now people export this data all the time to create PowerPoint presentations, and then it gets shared around. And so now you get this sprawl. So this data tends to be replicated and moved, and it moves all over the organization and outside the organization to conduct the mission or operations. And so in a typical enterprise, there's over 300 terabytes of data on average. In the government, in most organizations, it goes way beyond that. And so what we've seen, and everyone probably on this call already knows, is that that growth curve of data is growing exponentially, right? People expect to hit, the zettabyte range in the next decade. And so I don't have to tell a group like you why you have to care, because you've already taken the initiative to sign up. But essentially, you have unprecedented threats, right? Within the government, we've had threats against the government that are nation state threats like China, Russia, since we've been around. But now we're starting to see those threats evolve, that they're going after the defense industrial base further. They're going against private industry, which also affects our national security. So it's really a problem that's prevalent globally for everyone we do business with, not just the government itself. And so where they're going to get that data is off where the data lives, which traditionally is on a storage system like a NAS or a SAN. And traditionally, that data is not being protected the way it should be or adequately enough. And so we've seen tons of breaches coming out of NSA. I can tell you, right, insider threats are a huge challenge. They're not only a significant problem in that they represent 34% of the data breaches, but also they're very hard to stop because they're already on the inside. They already know how you operate. They know where the weaknesses are, and they can exploit that, right? We still, of course, have to protect against all the other cyber threats, the attacks, malware. We're even starting to see some of that ransomware being able to creep into government environments, especially that are on the low side. And so we need to have a capability that can protect data where it lives on the storage itself. And by putting that storage protection, putting that protection as close to the data or where it resides, you can eliminate any gaps between the security control and the data itself. And traditionally, when people think of cyber tools, we often think of network tools. We think of firewalls. We think of the perimeter. But in reality, we're defending the network to prevent them from getting to that data, because that network's the road to the data. But what the adversary is truly after is the data itself. So we want to make sure we're protecting the data all the time, and paying attention to that all the time. And so based on our experience working at NSA, looking at and managing systems, trying to develop a system to manage and manipulate large-scale operation and large-scale data, we realized that the storage was the weakest link, right? We're trying to bake in the security into the storage so that you're not, applying things like encryption on top, or trying to do the compliance and audit after the fact, because then it's not real time. And so to do that, we've created a zero trust architecture. I'm going to talk to you about that, but I'm also going to talk to you about how do you implement a zero trust architecture in your environment. And so with the cyber converged solution, what we're doing is we're giving the security team insights into who's accessing the data so they can determine what's happening all the time, and intelligence they haven't had before. And then the infrastructure team tools to find data, see what data is stale, see what data is overexposed, being able to put controls in the data owner's hands versus relying on the sysadmin. Because part of the problem we see today in the environment is that if you think about the sysadmin, they have a lot of control and they have a lot of visibility potentially into what's happening, but it's the data owners that know who should have access to the data. So you think about a project manager, they know who's working on the project, they know what files that individual users need to have access to on the project, they know who's read in and who's not read in anymore. The sysadmins typically aren't aware of what's happening day to day on the project. Somebody might move from project 1 to project 2, but not move out of the organization. And so those controls to de-escalate privilege or to remove access don't necessarily kick in all the time correctly. And the data owners don't have the visibility to see what they always have access to, or to see if they have compartmented data still in their personal directory. So what we want to do is provide the tools to the people that can make decisions and know what's going on. And that's part of the zero trust architecture in the way we see it as well. And so in 2020, according to Gartner, an analyst firm that you probably guys are familiar with, the top 3 security issues were ransomware, insider threat, data theft and spillage, and compliance, right? So I know these are issues that are popular among the SAP community, specifically the last 2, right? Insider threat, making sure that there's no insider threat stealing data or compromising data. And then of course, data theft and spillage. Spillage is a big issue, being able to show that data is not in an area it doesn't belong, right? It's common that we inadvertently might move data to a place it doesn't belong, but how do we detect that? So we want to be able to use things like labels and other reports to know that all the data is where we expect it to be and it's not where it isn't, or if we clean it up, that it's gone. And then from a compliance standpoint, compliance is really the demonstration of those security controls. So we need to make sure the security controls are easy to implement, that they're there, and then that we can also demonstrate those controls are implemented and we're following them. So we need reports that are coming out and are directly exportable from the data solution itself in order to comply with things like the JSIG RMF. And so how did we get to the point where we have this kind of situation where there's data everywhere and it's hard to tell what's going on in the environment? Well, if you think back not too long ago, I know Jason Moore said that the original guidance was from 1972 for some of those things, and things haven't varied a lot for what we want to do. But the challenge of the past has been that we've traditionally relied on fences and physical barriers and a perimeter to say, hey, once you're inside this area, if you're working in this office or you're past that perimeter, even if it's a network perimeter, you're a trusted person and you can have access to this stuff. And then once you have access, you're in that trusted core. The problem is we can't live in that environment anymore. With something like an insider threat, if they have access to the data, they can easily get access to everything and steal it. And now that we're living in an environment with the cloud, it's not a simple singular environment. Data is everywhere. Data might exist on premises. It might exist in the cloud. So this type of linear access that, hey, once you're inside, you're close to the data and you're accessing it, you're trusted, doesn't work. It doesn't protect the data adequately enough. And so this is why we need zero trust. Zero trust really says, hey, we're going to change that traditional model and we're going to add more controls and more segmentation to ensure that you only have access to the data and information you need access to. And we're verifying all the time that you're really who you say you are and you still need access to that data. And so we want to segment that as much as possible. And if you think about classifications, right, least privilege, only providing information you need to know, right? Even though you're cleared for something doesn't mean you're allowed to see everything or should see everything. You only should see the things you need to know to accomplish your mission or your job. And so zero trust is really in that same spirit of minimizing exposure of information and data and information systems to only the people you need to know so that you can reduce overall risk. And there's multiple things to a zero trust architecture, right? There are the network things that people are doing, and I know Palo Alto is doing stuff on the network side of things. There's things like multi-factor authentication. But when it comes to the data, there's a lot more that can be done to secure the data, especially the unstructured data that is traditionally not being done today. And so we all remember the saying, trust but verify. We're now moving to a never trust and always verify model. And that's what really zero trust is all about. And so it's important to remember the bad guys don't steal networks, they steal data, right? So we want to put the data in a place that's protected, but accessible and usable to do the mission or operation. And so cyber convergence is that example of putting the data in a secure container, but allowing you to do all the things you need to do and not hindering the mission or the operation. And so it follows the approach of zero trust in the fact that if you think about a bank, if you were to go into a bank, you walk into a bank, you look at the building, there's only one way in and out of that bank. There might look like there's windows, but they're either fake or they don't open, right? So you go into that bank and there's a visible guard, you go past that perimeter boundary. Then once you're in the bank, there's another set of layered protections, right, to get to that vault with the money. And in this case, the data would be that money, right? So you got to go past the desk and then you open the vault. And once you're in the vault, then you can get access to the data. But they're putting the strongest protections, that vault, as close to the money as possible, right? So the money is in the vault, except for whatever is needed to do the daily business of the day is brought out to the cash register. So to get to that vault, you're going through multiple layers and they're validating, hey, you need access to the vault. If you're getting here, there's multiple keys. That's the same concept that we're following with cyber convergence. We're putting the security and protection as close to the data as possible by storing the data on something with the security and validating who the user is that needs access to the data, what's normal, and all that stuff. And I'm going to get into that coming up in a moment. And so the challenge is, that you guys are all probably facing is that with zero trust challenges, it appears to people that you can't retrofit things. It requires a greenfield and it requires a current experienced workforce, which we know getting cyber experts right now is very challenging because not only is even in this environment, it's hard to hire skilled experts that are, IT, cybersecurity, storage experts, but also to get them that are also cleared is even harder. So it's a challenge. And then with siloed architecture teams, you have, traditionally people that are doing storage, then you might have different people that do desktop. Those add more challenges because it becomes complex and complicated to implement these type of environments. And then there's been a focus on the network focus versus the data focus, right? There's cybersecurity, as I mentioned, has been very network focused, but really we got to think about what are we trying to protect? And we also need to think about more dynamic controls, not the static type of controls we're used to where we set passwords and we do this, we set it and forget it. We really have to be dynamic. The threats are evolving very quickly. If you think about ransomware, originally ransomware just kind of encrypted your data. Then it was easy. It was going after kind of known exploitations and kind of old stuff. But now what you're seeing is a more dynamic, faster moving adversary. And they change their tactics and they change how they do things. And so now, once they realize people had backups and they weren't paying the ransomware, now they'll do data exfiltration to get a copy of the data before they start encrypting it. And really, the encryption part is just I'm proving to you I have your data. And if you don't pay me the ransom, I'm going to release the data, so pay me the ransom. So we need to have dynamic security controls that are looking at these changes and using a dynamic defense to go against these type of new adversaries and challenges. So, you know, if you think about kind of maybe even your environment today, we looked at very bolt-on approaches. And this is kind of the problem I struggled with when I was in the government, which was I deployed all these capabilities and I'd buy a capability from each vendor, and then I'd have to bolt on security tools, I'd have to bolt on compliance tools. The challenge is between the security and compliance tools and the data storage, I required privileged accounts. So now I need a privileged account on the compliance tool that can go scan and read all of the data that's on that data storage. What's the challenge there? Well, the problem is that privileged account could be hacked by an APT. It'd be very difficult for me to detect, that they're actually exfiltrating data through that compliance account, because it's normal for that to be scanning all the data all the time. It also has the effect of taking up IOPS and throughput to do compliance scans. That's when, you know, your user base gets upset because they're saying, well, it's slower than it used to be because we're doing all this compliance stuff. And then you have problems with, you upgrade one product and then the other one's no longer compliant, or it doesn't recognize special characters, and the compliance software isn't in real time, right? How fast can somebody get into your data, start doing stuff, and then clean up the logs if it's not in real time? We want to have something that's protecting the data in real time and feeding your SIM and SOC real-time events about what's happening as well. And so the approach that we believe in for a zero trust architecture to eliminate those seams is really consolidating or converging these capabilities. And you're seeing this throughout the industry. If you think about hyperconverge for virtualization, it's the same concept, condensing those things. The iPhone's similar as well. You took mobile computer, a phone, and a digital camera, and you created a converged device that's much more efficient, easier to manage, and easier to use. The same thing is true for security, we believe, with data storage. We need to embed the security capabilities into the data storage as much as possible. So doing things like encrypted disk, so using self-encrypted disk so all the data is encrypted at rest, then doing another level of encryption at the data set or volume so that individual data sets or volumes can be encrypted and they can be replicated to another location with a unique key. And then being able to detect and monitor the changes, right? So a system admin makes a change, we want to know that. We also want to know if a user interacts with the data, what they're doing and what's happening. And then we need to report on this to be able to show compliance with our accreditors, to show that we're operating an accredited information system in accordance with our risk management framework and our processes as well. And of course, you know, encryption is only as good as the key management and how you control the keys. So you need a solution that's going to integrate with your key infrastructure and allow you to use the strength of keys that you need. And so that we talk about the cloud, and the cloud's a very powerful, very useful environment. But with the cloud, we need to have separation of duties and separation of controls. And by allowing your organization to maintain control of the keys that encrypt the data and not having that as a service provided by the cloud, you can ensure that even if they get access to that data and they get access to the backend controls of the cloud, they can't get access to the unencrypted data because you control the keys and you have the ability to manage that or revoke keys as well. Back to that zero trust thing, right? And so the next phase of data storage is all about securing the data. It's all about securing the data. I would argue today that most people aren't too worried about performance after a point, right? If you have enough cash, you can buy flash systems. There are powerful and fast enough systems out there that can do everything you want. It's all about making sure the data is secure and you're able to operate at those speeds as well. And so where we come from in this is that a data-centric approach to zero trust and an action list. So these are the things that I would ask for you to take home and think about. How would we implement this in our environment to achieve a zero trust approach, right? So what we need to be able to do is actually show and capture the interaction with data. So when I talk about the audit of interaction of data, we want to capture what a user did. So we want to have the individual user and the user that group belongs to access the data. And then we want to also know where they're accessing the data from. And that includes what IP, right? So are they at a specific virtual machine or virtual desktop that they always come from? Is it an application that should only access it from this set of IPs or these servers? Is it outside the environment? Is this coming over a VPN? Is this coming from an abnormal IP, right? Where geographically and where is this a normal machine? And then the operation type would be, are they doing a read operation? Are they doing a write operation? Are they moving files? Are they renaming files? Are they doing something that's different than this application normally does? And I'll tell you why that matters in a moment. And then the size of the operation. Do they just read a little bit of the file? Or are they constantly reading the entire file and they're going through all the files doing that? And then, of course, the time of day they do it and how fast they're doing it, right? So if they're doing this all after hours, that might cause some alarm. Maybe somebody's trying to do stuff after hours and trying to exfiltrate data and go unnoticed. Maybe it's abnormal because they're looking at data, or they're looking at data they don't normally look at, or they're looking at an amount of data that's more than the threshold. Like, this type of user doesn't usually consume this much data in this time period, or this time period on these type of days, like a Saturday. That could be reason to trigger an alert so that the SOC can investigate it, or it could be to immediately shut down that account, right? And we'll talk about that in a little bit. But going back to the operation type and that pattern is very important, because applications interact with data in a certain way. So if you, for instance, use something like a Word document, Microsoft Word opens that document in a certain way. It creates a new temporary file and of that, which is a copy of it, and writes that file, and then overwrites the old file once you're saving your changes. If a program came in and tried to write directly to that file, that would be something that would be suspicious. So these type of behaviors that are abnormal could indicate something like a malware or an attack. Or the way that a cyber attacker might surveil your environment might be different. So they might be poking around and going to areas that they shouldn't, or using, poking in and getting access denied. So looking at things like an access denied would be very interesting, as well as how normal operating systems go and scan and open the environment versus how an attacker goes and scans and opens the environment. So knowing this lower level detail can provide a lot of value into detecting an attacker and abnormal behavior that you can then alert on. Of course, we need to audit the admin interaction with the infrastructure too, right? So the admin has a lot of ability. We always want to put the admin in a point where they're using their admin account to do admin skills, right? They shouldn't be using their normal user account to do anything but user stuff, and they should only use their admin account to do admin stuff. And so by using a dedicated admin account and auditing their interaction with the infrastructure, we can ensure that we can monitor what they're doing. And in some environments, you'll have two-person control where you're making one person make the changes and the second person kind of approve those changes to make sure what's going on. And ideally, what we want to do is have that interaction that they're performing tied to a change control or a ticket ID, so that we can verify, hey, they did this work and this was the work that authorized it, and it all matches. So you need to do periodic checks to make sure they're doing what they said they would do, and that it matches, and that there's no changes to the infrastructure they're doing that could potentially weaken the infrastructure purposely or inadvertently, and then also make it available, make data available to them that shouldn't be available normally. And then I talked about this a little bit already, but it's important that your organization controls the keys. If you don't control the keys to your data and you rely on or trust, which this is all about zero trust, another organization to manage those keys, you have the potential that they always have access to that data or those keys. And if you think about further out, and especially in government programs, if you think about the chance that some of this data is going to be retained for 20, 30, 40 years, then we're going to have to make this data available for a long period of time. But we're also going to have to do data lifecycle management. And this is where some things like archival come in, where you're actually going to have to rerun that data through quantum resistant cryptography potentially. So you're going to need to be able to manage the keys from before, as well as manage that data and move it through an environment that you can then re-encrypt it with quantum resistant cryptography. So all these things about controlling the keys become more and more important, because if these organizations ever had access to your keys, there's potential that they will steal the key in one area and then use those keys in another area to decrypt the data. So it's important that you have total control of your keys and you maintain control of those keys. And then most important is managing and monitoring access control to that data, right? So we want the ability to make sure we know on a period of time who is accessing that data, where they're accessing it from. And this goes back to least privileged access management. So you need a way to easily understand at any time who has access to a data set by user and by group, as well as looking at users and groups to see, are the users and groups still accurate? Like, should this person still be a member of the group? And what shares or data do these users and groups have access to? And then looking at the data that exists and see, is there stale data out there? Do you have data sets that exist that have been out there for a long period of time that nobody's accessed? Because that's a potential for data that could be stolen with sensitivity in it, but is overexposed and doesn't need to be. So you want to limit that exposure as much as possible and eliminate or archive stale data. And you want to make sure your access controls are as tight as can be. And then if you know you have stale data and you're archiving the data, then you can put extra controls around that too to say, hey, this is archived or data that's never or rarely touched, right? So if somebody does go look at that data, that's a reason to throw a flag up and say, who looked at that data and why? And then you know, maybe there was a legitimate reason, but you know. But if nobody's accessing that, and then all of a sudden somebody does, it gives you an easy flag to go look and say, hey, is this an attack? Is there some sort of malware going on? Is there an insider threat? And look at it that way. So setting those boundaries can help you detect kind of missteps as well. And that goes into my next point, which is being able to determine normal user patterns by user type, right? So you want to understand kind of what your environment looks like. And I mentioned way back in the beginning, it takes about 7 months to determine a network profile about usage. And that comes from all the challenges of looking at the network, having to break encryption, which weakens your security posture. From the data side, this can be done a lot easier. Everybody that wants to access the data has to come to something like a file share or NAS, and they have to get authenticated, right, with Active Directory. So they're telling you who they are and what they want access to. So it's very easy to determine what a usage pattern looks like for a group or for a user very quickly compared to trying to monitor net flows to do that. You can quickly tell, hey, these are the people that access this. This is the community of interest of people that access this folder. And not only does it help you understand from a security perspective, but if you're moving old data and it's been around for a long time and you put it on a system and then you can monitor and see who actually accesses the data, then you can go have a conversation with them to find out how sensitive is this data, why are they using this data, what's the importance, what's the performance requirements around it, and make decisions, have a conversation with them to make sure that it is as locked down as possible. Because once you talk to the data owner, you can find out, okay, who really needs this? Because I found in very large organizations with historical data kept getting moved from system to system, but you lose track of the data provenance of who owns that data and who uses that data. So to implement a zero trust environment, you're going to need to know who the data owners are and who uses that data effectively. And then you want to send this information, all these logs, to a SIM or to a SOC or to a log repository to be able to monitor them and review them and then investigate and take action. And that goes back to investigating or stopping, or how do you react when you find anomalous behavior. So with a zero trust approach, what you want to do is when somebody kind of crosses the line of what you expect to be normal or something they shouldn't do, you could just alert and then start to monitor what they're doing through tools. And so, a lot of organizations will have endpoint monitoring tools. And so then they'll start recording potentially what that user is doing to see if it's malicious, or they might stop access to that account immediately. Because if you think about, maybe there's a cyber attack, and that cyber attack goes in through an application server that's not being monitored because it doesn't have compatible software, and then it accesses this data to then start exfiltrating the data. You might want to stop that exfiltration before it's too late, because if it starts happening on Saturday and nobody's there to look at it or investigate till Monday, you might want to stop it. So you might want to have something that triggers an automatic deny on that account. And this goes into the whole, if you even think about, for a long time, right, we all know, you've probably all been to like counterintelligence briefings where they say, hey, if you see something suspicious, report it. And you always see the fact that they find out somebody was a spy, or you have the Snowden type guy and they go, I always thought he was suspicious, or I saw him doing weird things, but I didn't want to say anything because I didn't want to get him in trouble in case he wasn't doing anything bad. I didn't want to report it. With this, the system itself, if you make it programmatic that you end their computer access, you can be sure that it's going to happen. There's not going to be any feelings involved. And then if they're really doing something legitimate, they're going to call to get their access restored. If they didn't, then maybe that's even more reason to go investigate what were they trying to do. But it puts these hard lines in the sand, and it can be more effective in doing that, creating that investigation, finding out what's going on. So that's my action list for creating a data-centric zero trust approach. Do you have any questions? Or?
We do.
Okay.
It is, will the system tell what is printed by file name?
Yes, so we can tell you the full path of what the file was accessed. So you'd see the entire path plus the file name. And you can then, we have tools so that within our system that you can actually search for an individual file. So you could see that file, and you could see in the case of data spillage if that file existed anywhere else as well, if there was a spillage event.
All right.
So this kind of shows you just an example architecture of what we've done to implement zero trust from a data-centric point of view. So you have your file protocols, and then we built the security and compliance suite into the storage operating system, and it runs on commodity x86 hardware. You can use direct attached disks or attached to a SAN via fiber channel, and you can even tier data to the cloud. And you have the ability to do this all in real time. And we take advantage of RAM to be able to do all the compliance and security in real time, like the encryption, like the auditing, so that it doesn't affect the user experience or application performance. And we could give you a demo of kind of how this works in real time as well. So, but if there's any more questions, that's kind of the conclusion of my presentation. And if you have any questions, feel free to reach out to me. If you want to go deeper into the zero trust architecture or how to implement that. Yep.
Oh, I do have a follow-up on that. So we can see who accessed a file, who modified the file, who deleted the file, everything, correct?
You can see everything. You can see if they renamed it. Any file operation we can determine, as well as if they change permissions on the file. So pretty much any file operation we can do. And we have the ability to filter if you just wanted to see writes or reads, but renames, changes, moves, deletes. So if somebody even inadvertently dragged and dropped a folder, which happens sometimes in Windows where somebody just drags and drops a folder into another one and they can't find it, you'd be able to find that folder, put it back, and then also determine who moved the folder. And then we have some videos on this. One's called Who Moved My Cheese. And then the other thing too is what's valuable in being able to see who wrote a file, the IP, and all that is if you did come under attack, if there was malware, ransomware, you could quickly attribute to what machine was infected or what account was compromised. So if you were hit with a ransomware attack and our system didn't detect it and stop it, we would be able to say this was the machine and these were the accounts that had the malware that performed the encryption.
Another follow-up, and I have another one after that. Is this in the cloud, or can we place this in our own enclave?
So it works both. So it deploys in your own enclave, or you can deploy it in the cloud as a virtual machine. So it's completely flexible. It's the same software if you either run it in the cloud or run it in your enclave. And we have a lot of experience running in SAP programs in enclaves and being able to replicate and protect your data effectively.
Oh, they're saying the questions are hard to hear from over here, so just
Okay.
repeat what I'm asking.
Okay.
So have you integrated with any audit reduction tools like Splunk to review those audit logs?
Have we integrated with any audit reduction tools to review the audit logs? Yes. So we have customers that use Splunk as well as Elastic Kibana to do the audit logs, and also VMware's tool, which is escaping me now. But they have a log reduction tool as well. And that's a common practice. Fortunately, our system outputs logs in the standard format, which is RFC 5424. So it's very easy to put it into any syslog environment.
That might be all.
And the previous question was, can we deploy this in the cloud or on your own organizational environment enclaves? And the answer is it's flexible. We have many customers that deploy it on their own organizational infrastructure. It deploys on, it can be a traditional NAS, like a NetApp or Isilon, or it can deploy as a virtual machine like on ESX or KVM, or you can deploy it in the cloud as well. And you can have them replicate between each other or replicate to the cloud or tier data to the cloud. And we can, if you're interested, reach out to us and we can give you a technical overview, just show you how it all works without any sort of sales pitch.
And I do have a question about obtaining a copy of the slides.
Yep.
I think, I'm not sure if we'll post them, but you can reach out to us directly, or I'll make a note of this question here and follow up with the slide deck for you.
Yeah, if you email the info at Racktop Systems, we can do it too.
Oh, one more. How is this licensed?
So it's licensed based on capacity. So we have very small, you can get a virtual machine that's about 5 terabytes to start, and it's a subscription for 1 year. The list price of that's only $2,000. And then we have large systems that scale up to multiple petabytes. About right now, our largest cluster before we would recommend going to a second cluster is about 6.5 petabytes usable, and it's all licensed based on usable capacity.
If anyone else would like a copy of the slides, you can leave a note in the panelist section, and I'll make a note of your name and follow up.
I appreciate everyone's attendance and attention. It was great. Thank you very much. And if you ever had any other questions, feel free to email me as well, technical or opinions or thoughts. Happy to talk about Zero Trust or get your input and have you share your thoughts. I'd love to get more feedback from you guys about your thoughts on Zero Trust overall as well.
Great. We have a lot of requests coming in for the slides,
Great.
so it's good to see. Well, thank you, everyone.